Start. Start.
ওকে, সো আমি গ্রুপে লিখে দেবো। Okay, so good afternoon, everyone. I am Purva Mukhopadhyay, Assistant Professor of IT Department of this institute, Bengal College of Engineering and Technology. So, a warm welcome to all the participants, esteemed speakers, and all the faculty members to this 5-day online enrichment program for GATE aspirants, jointly organized by the Department of IT, CSE, and CSE AIML. So this program is specifically aimed for the students of background CSE IT to help them in excel their GATE exams. Okay, so let's start today's session. And before we begin, I would like to thank all the faculty members, our respected directors, sir, principals, sir, and esteemed speakers, and also our guests and participants as well to make this event possible. So let's start today's session. Now, I would like and I am pleased to introduce our speaker of the day, Dr. Shantanu Modak sir, who is an associate professor and also the HOD of IT department as well. And today, he will be discussing the subject TOC, that is Theory of Computation, which is one of the most important subject for cracking and in terms of gates. So now over to sir. Sir, please start.
Thank you, Purva. So, although we are late for this session, so let's without further delay, let's start the session. Let me share the screen. Purva, is it perfectly visible?
Yes, sir, it is visible.
Okay. Okay. So now start the very important topic in terms of GATE exam, that is theory of computer science. So it's a branch of computer science which deal the fundamental capabilities and limitation of computers. Let's start with a famous hierarchy that is called Chomsky hierarchy. In automata theory, theory of computation, you know there are four types of grammar. These four types of grammar are basically come in form of Chomsky hierarchy. Chomsky hierarchy is basically the classification of formal languages. Here we specify some types of grammar. Let's start with some generic terms. Generic term means first one is variable. Variable always the finite set. In terms, it is called non-terminal. Generally, in theory of computation, it is written in capital letter form. Generally, it's not mandatory always, but generally, it is written in capital word form like S. Okay, terminal. It's generally denoted in this sign. It is also finite set. Variable is finite set. Terminals is also finite set. Finite set means it should be countable. It should be countable. In any grammar, number of variables must be countable, number of terminals must be countable. Okay. Generally, terminals denote in small letter form like small a, small s, small c. Variables are used to continue the string. Terminals are used to stop the whole string. Okay. These are the two main parts of every line. Now there must be a start symbol. There must be a start symbol. Start symbol is also part of variable. Start symbol is also part of variable. And there are several rules, also called the production rule. And based on the variation of production rule, the grammar can be classified into four different categories. Okay, if we denote variable as V, terminal as sigma, start symbol as S, or roots in the form of R. So now I will describe you how the grammar will break into four different categories based on the Chomsky hierarchy. Okay, and if you have any question, just write in your YouTube chat box. Definitely I will try to solve your doubts. Okay, so first one is type 0 grammar. In type 0 grammar, the production rule are in the form of alpha determines beta, where alpha and beta alpha and beta both are the string of non-terminals and terminals. Generally, if we break alpha union beta, alpha implies beta, it will denote like this: V union sigma star. V again V union sigma star, which determines V union sigma star. So V means variable or non-terminal. Union, you know, it's normal discrete mathematics union. Sigma means set of terminals. And star. In theory of computation, you can find two type of closure symbol. One is the star closure, another one is the plus closure. What is the difference between these two? In star closure, any number of possible string starting from 0 means this string can occur any number of time starting from 0. Means if it is never occur, then also it is satisfied. If it is one time occur, also satisfied. Multiple time occur, that also satisfied. But in plus closure, it start from 1 to infinity. That is the difference between star closure and plus closure. Star closure means 0 to infinity, and plus closure means 1 to infinity. And the star closure is also called the clean closure. Okay. So means any number of variables and terminals. And here also any number of variables and terminals. It also any number of variables and terminals, but only one restriction is there. In left hand side of every production rule, there must be at least one non-terminal. At least one non-terminal must be there, and proceed to the non-terminal. Any non-terminal and terminal can happen. Followed to the non-terminal, any terminal and non-terminal can happen. And in the right side of production rule, any number of non-terminal and terminal can happen. This is the most generic structure of the grammar, and it is called type 0 grammar. Is it clear? Just write in the YouTube chat box. Let me see. Any question is there or not. Is it clear to everybody? Please write. Okay. So now come to type 1. Type 1 grammar means from type 0 grammar we can imply one more restriction. From type 0 to type 3 we will implement one by one restriction. In type 0 this is very general structure grammar, and it is called the phase structure grammar. In type 1, same format of production rule is applicable. Same. Alpha determines beta. Alpha means V union epsilon star. Union epsilon star implies V union epsilon star. Same. Type 0 production rule and type 1 production rule are same. But only one restrictions are there. What is the restriction? Restriction is length of the alpha should be less than is equal to length of beta. Length of the alpha, this is alpha and this is beta. So length of alpha should be less than is equal to length of beta. What it means? It means less number of symbol can produce more number of symbol. Am I right or wrong? Because in left hand side we find less number of symbol. In right hand side we can find more number of symbol. So it means that less number of symbol can produce more number of symbols, and this is called length increasing grammar. Rest are the same as type 0 grammar. This is called length increasing grammar. Always keep remember this term. Sometime you got question from this term also, and definitely you will get at least one question from this term. Okay. So that other name also there. The name is context sensitive grammar. Generally, it is called the context sensitive grammar. I think type 0 and type 1 are clear to you. If anybody have any question, please write in the chat box. I can parallelly solve your question. Okay, very good. Very good. Now come to type 2. In type 2 grammar, we can apply restriction in the left hand side. Means in the left hand side, only one non-terminal are allowed. Here, at least one non-terminal or any number of terminal non-terminal, any number of terminal non-terminal. In type 1, length of this side should be less than is equal to length of this side. But in type 2, we apply the restriction in the left hand side of the production rule. So in left hand side, only single non-terminal is allowed. In right hand side, you can apply any number of terminal and non-terminal. In right hand side, you can apply any number of terminal and non-terminal. Okay, so this type of grammar is called the type 2 grammar, and other name is context free grammar. Context free grammar. Okay, this is type 2. Now come to type 3. In type 3, we apply the restriction on right hand side. Why right hand side? Because in left hand side, in type 2 grammar, we apply the restriction on left hand side. Left hand side should contain only one non-terminal. Means no more restriction can be applied on the left hand side. In right hand side, we can apply restriction in case of type 3 grammar. You can see the production rule are in the form A determines AB or A determines A. Means a terminal followed by a non-terminal or a only terminal. Sorry. Now, the total restriction applied on the right hand side. So, most powerful grammar is the type 0 grammar, which accept all type of production. The grammar is called the phase structured grammar, and it's accepted by the most powerful machine of theory of computation, that is called Turing machine. Type 1 grammar, we add more restriction from type 0. This is called context sensitive grammar, and it is accepted by linear bounded automata. In type 2 grammar, we apply the restriction on the left hand side of the production rule. Type 2 grammar is called the context free grammar, and it accepted by push down automata. Type 3 grammar, we imply the restriction on the right hand side, and that is the least powerful grammar is called the regular grammar, and finite state automata. Finite state automata is applicable for the regular language or type 3 grammar. So, already I told you that most powerful grammar is type 0 grammar, phrase structure grammar. Basically, any decision problem can be represented in formal language is part of type 0 grammar. Any type of decision problem. What is decision problem? Suppose we consider L is a decision problem that can be solved on computer if and only if L can be described by type 0 grammar. This is the part of decidability. This is the part of decidability. Is the problem solvable by a computer or not? If it is solvable by a computer, then we can write the type 0 grammar for that particular problem. If we can't write the type 0 grammar, then we can tell that the problem is undecidable. So, type 0 grammar are powerful enough to all computational capabilities of a computer. Means Turing machine. Turing machine is the machine which can solve the all concept theoretically of a digital computer. That is almost the same powerful machine of digital computer. Now come to type 1 grammar. Generally here rules are applied in form of context sensitive language, and linear bounded automata is applicable for type 1 grammar. Hope Chomsky classification is clear to you. If it is clear to you, please write in the chat box. It will help me to understand. Clear. Okay. Very good. So these are the hierarchy. Most powerful is type 0 language, that is recognized by Turing machine. Comparatively restricted is context sensitive, more restricted is context free, and finally most restricted is regular language. Now come to the closer properties of that language. That is also very much important. That is also very much important, because if you follow previous year gate question paper, then you can find at least one or two questions came from closer properties of language. Sorry, I am trying to put up all closer property related previous year questions in few slides. It will helpful for you to memorize all closer property within 4 or 5 slides. Okay. And after the lecture, if anybody wants to get this PPT, just inform through the YouTube comments. Definitely, I will share with you. Okay. So first one is union. Union means if you take closer of to language, it can be either language. What it means? What it means? Let's take some example. Till now, I am giving you the form of grammar. Although I don't discuss anything about language till now, so let's discuss something about the language. Then the closer property will be clear to you. Suppose L1. L1 is a to the power n. A to the power n greater than is equal to g. The language is regular language. Why it is regular language? Because if we can draw a finite state automata for this language, then we can say it is regular language. Although drawing final state automata is not saying that language is regular, uh, there are some other laws also, like pumping lemma, Myhill-Newton theorem, all are there. To pumping lemma is used to prove the language is not regular. Myhill-Newton theorem used to prove the language is regular. But for a generic sense, if I say you, is the language is regular? Obviously, the language is regular, because you can draw finite state automata for this language. Suppose Q0 is a starting state, and it's also a final state, and you round, take a self loop on this on a. So any number of time it can repeat, that represent this. So basically the language is regular. Now come to another language, L2. L2 says that a to the power n, b to the power n, and the condition is same, n greater than is equal to 0. Is the language regular? No, the language is not regular. Why? You can say that I can add one B here, so it will count n number of times. But 2 to the power n both are same. A to the power n, B to the power n are same. And self loop means it's not guaranteed that A and B will repeat at same time. If I write it in the form L3, A to the power n, B to the power m, n comma m greater than is equal to 0, then it is a regular language. You can prove this language by this diagram, because n and m are two different variables. So A can run any number of time, B can run any number of time. That time the language is regular. But when both number are same, means you need some memory to store the A. But in finite state automata, you don't have any memory. If we add one stack with finite state automata, then you can count this number of A, you can push a plate on the stack. Suppose n is equal to 5 in case of L2. For a particular A, you add one plate in a stack. When you got B, you pop one plate from the stack. Then easily it can be proved that language is proved. But in finite state automata, you can't add stack with a FSA. So if you add FSA with one stack, it becomes the push down automata. So this language is not a regular language, it is context free language. Is it clear? This language is regular, this language is also regular, but L2 is a context free language. Now we come to L4, where I write A to the power n, B to the power n, C to the power n. Means for three variables, inputs are same and n greater than is equal to 0. Is it a context free language? The answer is big no, capital N and capital O. Big no. Because by using a single stack, you can compare at most two variables. Like a to the power n, for A we can push a plate, for B we can pop a plate. But same number of is repeated for C. If I write one language L5 in this form, A to the power n, B to the power n, C to the power m, D to the power m, then it is a context free language. N, m greater than is equal to 0. Then it is a context free language. Why? Because for A, you can push a plate on the stack. For B, you can pop a plate from the stack. For a C, again you push the plate on the stack. For D, you can pop the plate from the stack. So L5 is a context free language, but L4 is not a context free language. For this purpose, you need two stacks. One stack is not sufficient for this type of language. For A, you push a plate. Suppose you have two stacks. That is stack 1 and another one is stack 2. For A, you push a plate on here. For B, you pop a plate from here and push the same plate here. For every B. Suppose you have 3A, 3B, and 3C. So for A, push one plate. For second A, push another plate. For third A, push another plate. For first B, pop one plate from here and push here. For second B, pop one plate from here and push here. For third B, pop this plate and push here. For first C, pop this plate. For second C, pop this plate. For third C, pop this plate. So for this type of language, we need two different format, and the language is called context sensitive language. The variation of the language is clear. Please write in the chat box. Let me check. Yes, type 1 is context sensitive and type 2 is context free. Okay. Now come to the closure properties of language. Union. Union of two language set all strings that are either language. Okay. Concatenation, same. It can be form of second language. Concatenation means common of that part. Okay, one by one I give you example. First one is regular language. Regular language is closed under union, concatenation and intersection. What is concatenation means? Concatenation means by basically adding to language. And intersection means the common part of the language. Complement means just opposite of the language. Okay. So regular language, for regular language, this is closed under We are sorry that we found some technical difficulties due to bad weather. From tomorrow, we will complete the lecture as per the schedule. Hope you enjoyed today's lecture. I will share the feedback link and attendance link in WhatsApp group for today's session. From tomorrow onwards, we will post on the YouTube chat box. Okay, so hope you enjoyed today's session. If anybody needs this PPT, you can write in the chat YouTube chat box or YouTube comment section. Definitely, I will share with you the PPT. So thank you once again. Thank you for the cooperation. Let's conclude the session.